Analyzing conic sections, parabolas, ellipses, and hyperbolas. Hello everyone. Today, we're going to dive into the fascinating world of conic sections, specifically parabolas, ellipses, and hyperbolas. These shapes aren't just abstract mathematical concepts. They appear all around us in architecture, astronomy, engineering, and even everyday objects like satellite dishes and car headlights. Understanding how to analyze their equations is key to unlocking their secrets. So, let's get started. First, let's briefly define our stars of the show. 1. Parabola, a U-shaped curve that is mirror symmetrical and has a single focus and directrix. 2. Ellipse, an elongated circle, also known as an oval, with two foci. 3. Hyperbola, consists of two separate curves called branches, each with its own focus. Each of these shapes can be represented by a specific type of quadratic equation. Our goal is to take any given equation of these forms and analyze it to find key features like the center, vertices, foci, and axes of symmetry. Let's begin with the parabola. The standard form of a parabola that opens either upwards or downwards is y equals ax minus h2 plus k. Here, hk represents the vertex of the parabola, and the value of a determines how wide or narrow the parabola is. If a is positive, the parabola opens upwards. If negative, it opens downwards. Take this equation for example, y equals 2 of x minus 3 square 2 plus 4. To analyze it, vertex. The vertex is at hk, which here is 3, 4. Direction. Since a equals 2 is positive, the parabola opens upwards. Width. The larger the absolute value of a, the narrower the parabola. Here, a equals 2 means it's relatively narrow. From the vertex, we can also find the focus and directrix, but we'll keep it simple for now. Next up is the ellipse. The standard form of an ellipse centered at hk is frac x minus h2 a squared plus frac y minus k2 bt equals 1. Here, a and b represent the distances from the center to the vertices along the major and minor axes respectively. If a even b, the major axis is horizontal. If ba, it's vertical. Consider this ellipse. Frac x plus 2 squared, 2, 16, plus frac y minus 1, 2, 9 equals 1. Analyzing it, center, minus 2, 1. Major axis, since 1609, the major axis is horizontal. Vertices, along the major axis, they are a equals 4 units from the center, so at minus 6, 1, and 2, 1. Minor axis, b equals 3 units, so the co-vertices are at minus 2, and minus 2, 4. Understanding these parameters helps in sketching the ellipse accurately. Lastly, let's explore the hyperbola. The standard form of a hyperbola centered at hk is either frac x minus h at 2 a's frac y's k squared equals 1, quats tech frac y pay 2 b squared 2 a squared equals 1. The first form opens horizontally and the second opens vertically. Take this hyperbola. Frac x minus 1 squared of 2 5 20 frac y plus 2 2 9 equals 1. Breaking it down. Center. 1 minus 2. Orientation. Since the x term is positive, it opens horizontally. Vertices. A equals 5 units from the center at minus 4 minus 2 and 6 minus 2. Conjugate axis. B equals 3 units, helping to determine the slopes of the asymptotes. By identifying these key features, center, vertices, axes, and orientation, we can graph each conic section accurately. Whether it's a parabola soaring upwards, an ellipse gracefully elongated, or a hyperbola stretching into infinity, understanding their equations empowers us to visualize and apply them in various contexts. In summary, analyzing the equations of parabolas, ellipses, and hyperbolas involves 1. Identifying the type of conic section based on the equation's structure. 2. Rewriting the equation in standard form to easily extract key parameters. 3. Determining features like the center, vertices, foci, and axes of symmetry. 4. Sketching the graph using these features for a clear visual representation. Mastering these steps not only enhances your algebraic skills, but also opens doors to exploring real-world applications, where these beautiful curves play a pivotal role.